I'm going to show you an example using kind of a generic metal, M, and instead of you all are using magnesium. And then let's look at how the reaction works and everything. You're going to they have you use a watch glass, and I'm not putting one on top of my evaporating dish, but it doesn't matter. Just consider the evaporating dish and the watch glass to be one thing, one container. Okay, so what you'll do is you'll weigh your evaporating dish. This is the evaporating dish. You'll weigh it empty first, and then you'll put some metal in it, and you'll weigh it again, so that way you can get your mass of your metal. And then you're going to add some solution of hydrochloric acid. And the hydrochloric acid will make it bubble. So the hydrochloric acid is aqueous, so that's adding water to it as well. And it'll start to bubble, and it bubbles because of this product here. Okay, and the thing is it's making, as it goes, it's making this compound here, and this is the one you're interested in because we want to figure out what that X is. Okay, so that compound is forming, but it's in there with the water. So then after you react this until it's not bubbling anymore, you want to get that compound, which is your metal and your chlorine combined. You want to get the mass of that. So what you do is you heat it on your evaporating dish, and all the water leaves. The water that was part of this aqueous solution leaves. And what you're left with after it leaves is that you're left with just your magnesium and your chlorine, and of course they're in a compound. It's this stuff. Okay, and because you have your mass of your empty container, you can figure out the mass of this in there. So let's just summarize what is in the dish. So to start with, you have an empty dish, evaporating dish, and you'll have a watch glass, but anyway, it's empty. You have the mass of that. Then you'll have the mass of it with some metal inside. And then after the reaction, you'll have the mass of the dish, and you'll have the metal and the chlorine. And of course, these two will be in a compound, but it doesn't matter. So this metal, this mass of metal, is the same as it is there. Okay. So at the end, when you weigh the whole thing, you'll have the metal, which you know its mass, and you can figure out the rest is the chlorine after the container. Well, let's look at an example problem. So I'm going to do an example problem using my generic metal, and again the goal is to find this X, which gives us the empirical formula. And these are the numbers that I need to use. I have my empty container, my container with metal, and how much it weighs afterward after it reacts. And so that's pretty straightforward. This here, after it reacts, this is going to be the container with the metal and the chlorine. So it's the dish plus the metal and the chlorine. Okay, so let's start by calculating the mass of the metal. And to do that, I'm going to take the mass with the container, so the dish, plus the metal, and subtract off the dish. Okay, next I'm going to you could do this in different orders, but I'm doing the same order that LabFlow does. I'm going to calculate the mass of the product, and the product is this right here, these two. So I'm going to take this as my total and subtract off the dish again. Okay, and then from that I can get the mass of the chlorine. So I have this mass of both. And then above I have the mass of the metal. And that gives me the mass of the chlorine. And so now I'm going to use this mass of the metal and this mass of the chlorine and figure out the ratio of those. But remember, to get the empirical formula, I don't need the ratio in terms of mass. You know, like I can't do this. Oops. I need the ratio in terms of particles. And so this is where we convert those to moles. And this is where you need to use a molar mass, and I put one up above for my fake metal. And I'll do the same thing with the chlorine. You want to use extra digits on this, so I have a little bit more. We only have 2 sig figs in our given masses, at least I do, and so that kind of has some error to it. And I see where I made a mistake. This number should be down here. It goes with the grams. Okay. And then for each of these, I'll multiply or divide them out. And then on Webflow or LabFlow, it has you record these numbers, and I recorded extra digits, which is good for your next step, and it did not mind or count off, so it's okay to record. Don't follow your sig fig rules on that, because if you do, then you might introduce extra error. We don't like to over round. So at this point, I do have a mole ratio, but what I need is I need to have it whole numbers. You know, I can't use 0.0057. So what I do is I divide by the smaller, of these two numbers, which is this top one. And of course here I get 1. And here I got 3.05. But we know that this should be a whole number. And the reason that an integer, and the reason that it's not is because of our error in this number. It only has 2 sig figs. So I'm going to call that a 3, and that is a 1. And so our ratio here is that we have 1 of the metal for 3 of the chlorine. So my empirical formula is metal Cl3. And like I said, that's the number I determined. Yours will not probably be a 3. You need to figure out what yours is. I wanted to show you one last thing, and that's on this data that they give you. You know, what's what. So they give you, this is, first number is just like your dish. What I used is my dish. It's the container. The next number here, they make it sound so long, but basically it's the dish and the metal. And the last one, it's the dish and the metal and the chlorine. So it calls it the reacted magnesium, but it has the chlorine in it. And that should be all you need to know.